Hello students, welcome back to Chemistry Online class. We are treating some questions on entropy and spontaneous reaction. Now, if a reaction is spontaneous, the entropy will be high, the temperature will be high or moderate, and the enthalpy change, which is the heat of reactant, will be very low. Now, so entropy is the degree of disorderliness in a substance, and it is higher in reaction involving a gaseous phase. In which of the following is the entropy change positive? That is, in which of the reaction below, the following reaction is entropy change positive, that is, requires a reaction in gaseous state, because it is expected that if a reaction is in gaseous state, the entropy will be higher, degree of disorderliness is higher. So the first one here, water changing from liquid to gaseous state. Copper 2 ion plus iron solid to form iron 2 ion and copper solid. That I don't think there's a change in entropy. There's just a change from solid to liquid here. So there's no increase in entropy. Nitrogen gas reacts with hydrogen gas to form ammonia gas. Everything is in gaseous state, meaning that the entropy is constant. Hydrogen chloride gas react or dissociated to form hydrogen gas and chlorine gas. The entropy change here is also constant. That is, everything is in gaseous state. So the best option is option A. That is, water changes from liquid to gaseous state, like steam. So it means there's an increase in entropy, or the increase in the state of disorderliness, or randomness of a body, and that is entropy. So definitely the entropy here will be positive. So the best answer here is option A. Now we have related questions here: 1999 question 25, 2001, 2008. You will see questions on entropy. We also have 2009, 2010, 2015, 2012, 1997 question 26, 2013. We also have 1995 and 1992. We can also get more on those questions, on this aspect, which is the entropy. The next question: if a reaction is exothermic and there is a great disorder, if a reaction is exothermic, it means that reaction is negative. The heat, that is the enthalpy, delta H in that case, is negative. That is exothermic, and there is a great disorder, meaning that the delta H, as a change in entropy, is positive, because there's a great disorderliness. It means A, the reaction is in a state of equilibrium. There will be a large increase in free energy. There will be a large decrease in free energy. And the last option, the reaction is static. And so for a reaction to have, for the free energy of a reaction to be decreased, I'm going to use this shortcut, delta H minus T multiplied by delta S. That is the free energy. Now for a reaction to be spontaneous or occur easily, that the free energy must be negative. How do we get all this to give us a negative answer? It means this must be very low, like negative, as in negative, like minus 20. Then this entropy must be very high, like 10 multiplied by 15. Though temperature here must be always be in Kelvin. So let's say we have 15. I'm trying to avoid higher numbers so that when multiplying to not be too complex. Now minus 20 minus 15 times 10, that's 150. We're going to end up getting a negative value, a kilojoule, as the free energy. So in this case, the free energy is negative if and if only the temperature and the entropy, especially the entropy, is higher, and everything here is higher than the enthalpy. Even if the temperature is lower, multiplied by the entropy, provided the entropy is greater or higher or positive, multiplying it with the temperature in Kelvin, by the time you deduct it from delta H that is lower, you're going to get a negative answer. So in that case, if the free energy is negative, the reaction is spontaneous. And so here now, the reaction is exothermic, meaning that the enthalpy H is negative, and there's a great disorderly, that is, the entropy is higher. The reaction, there will be a large decrease in free energy, and the reaction will be spontaneous. So the best answer here is option C. Then the next question, I'm moving over to this calculation. I will treat this question last. But this one, a reaction occurs spontaneously when I told you earlier that if the free energy is negative, the reaction will be spontaneous, meaning that reaction, you don't need to put in more energy. You don't need to, it doesn't require a very high energy for the reaction to occur. So delta G here is greater than 0. It means the free energy is higher here. If the entropy is less than 0, and the enthalpy change is greater than 0, no. If the enthalpy is greater than 0 and entropy is lower, the reaction will not be spontaneous. The reaction will not be spontaneous because if the enthalpy is higher and this is lower, you will get a positive answer. Higher and lower, you get a positive answer. And if this must be negative, this free energy must give us a negative answer for the reaction to be spontaneous. So here, if the change in enthalpy here is less than the product of temperature and entropy, definitely we will get a negative delta G. That is, if the product of temperature and change in entropy is higher than the enthalpy change, that is the heat of reaction, like this now, enthalpy is less than the two of this, the product of these two, definitely we'll get a negative value. And so this will make the reaction to be spontaneous. But let's check the last option. If the free energy is greater than 0, no, if the free energy is greater than 0, the reaction will not be spontaneous. It means it requires a great energy for the reaction to occur. And the last question here is, so the best answer here is option C. The last question is a chemical reaction with entropy change of 20 kilojoule and free energy change plus 55,000 occur at minus 23 degrees Celsius. Calculate the enthalpy change. So using that, we have delta G is delta H minus T delta S. Now, entropy is already 20, meaning that this change in S is 20 kilojoule per mole. Multiplied by temperature, minus 23. Temperature is minus 23. Don't forget the temperature must be in Kelvin. So we need to add this to 273. That should give us 296. 296 minus this. Oh, that should give us minus 23 plus 273. That should be 250. 250 minus here. Then the change in enthalpy. Let's see, what are we calculating? And the free energy. Again, a chemical reaction with entropy change of 20 kilojoule. That's delta S, and free energy change, this is G here, of plus 55,000 kilojoules or joules, 55,000 joules, occurred at minus 23, which is the temperature, and it has been calculated as 250 Kelvin. What is the enthalpy change? Calculate the enthalpy change. That is delta H. So getting this, we need to multiply 250 and 20 together.